Okay, in this part of this video, I would like to discuss more detail about the block mesh, specifically about the use of grading. So the grading is very useful if you want to make an efficient mesh. Let's say if you want to focus only on the near wall boundary layer. If you know about the boundary layer, you know, like the zero velocity near the wall that makes the flow that makes the velocity gradient near the wall high. And we know that if we have the high gradient, we need to have a good resolution of mesh. But if we make the mesh with the higher resolution all over the place, that will make our mesh not efficient. So we will need a lot of computational efforts, and at the end of the day, the computational will be very costly in terms of time and hardware resources. So by using the grading technique, we will make the mesh more efficient. So let's just try using the new case. So here I will describe three of grading techniques, which are the simple grading, and then edge grading, and the multi-grading. Let's first we copy and paste our trial folder, and maybe trial one, because I just want to make a simple demonstration. If we use three blocks like the previous part like this, it will be take long time to explain it. So just to make everything simple, use this trial one, and make it trial 3. But before we edit or before we run, we make the block the same direction or the same size in every direction, so it will make our our example more obvious. Just take our block mesh, then let's make the z direction also 1 meter, so we have all 1 meter in 3 dimensions. Let's open our WSL as usual. I hope you get used to this the workflow. So go to the go to the projects folders and trial 3. Let's check our cavity, then run the block mesh. We don't have any change so far. We just make the the box bigger or 3 dimension, or maybe, oh, I forget something. If we change the mesh with the same size in every direction, I must make it also 50 in the z direction, so we can make the distribution of the resolution even regular. So just touch foam.foam, and I prefer to like drag and drop here, because it is easier if you want just to reload the file. So it's your preference. If you want to connect it with the from here, it is also no problem. You can use ParaView, but you need to modify some specific variable, but it will not be issue. I prefer to use this manual method. It is more controllable, in my opinion. Okay, I need to delete this first to make our case simpler. Okay, just drag and drop this, and let's see our mesh. Now we have a three-dimensional box with the same size in every direction and same resolutions in every direction. Okay, just go to the simple grading. The simple grading just works basically like this. Sorry. This simple grading is basically works in the X, Y, and Z. So basically we use the simple grading with the parameter of 1, 1, and 1. Let's say I want to make a simple grading in the X direction. Let's say I want to make it like 2. So 2 is basically the ratio of the expansion ratio. So the number here is the expansion ratio. So if we input 2, it means that every size of the cell will be has a ratio of 2. Let's just see the result by running the blockMesh and touch again and reload. So in the X direction we can see that we have the ratio of 2 from this size to this size. So yeah, maybe to make it more obvious I will make it like 10 maybe, and maybe for faster computation and faster video duration I will reduce the resolution. blockMesh, then touch again, here we go. We get the 1 divided by 10 or 10 ratio, 10 expansion ratio. If we want to change the direction, because this is the in the X direction, this is the 1 and this is the 10, I can change like 0.1 if I want to make the other direction. Just check this. Touch foam, then here we go. It will be in the other direction. We can also make it for the Y and Z, but maybe we'll not do that because you know the result. And we will check the other method. We can also make the grading in the format like this. So this ratio, we can divide it into 3 ratios like this. So let's change our format so we can easily read this. Simple grading, it is basically just like this. Simple grading, it is in the X direction, then in the Y direction, and in the Z direction. This is basically the same. And I want to make the Y direction into the other format, so the format is like divided into 3 parameters, which the first parameter is the this number, this ratio, then this is the ratio, and this ratio. Let's try this. Try to use like the 10 and 1 and 0.1, let's say. blockMesh again, then touch again. We make the alteration for the Y direction, so we can see here like the 10, 1 and 0.1, the ratio. Okay, it is the first technique, which is the simple grading. And okay, and for the more advanced thing, we can use the multi-grading. So inside this folder, so I will rename it as X so we don't get confused, and this is the Y and this is the Z, and we can even more expand this into this form. So this is more complicated or more advanced form. Let's make it this format so you don't get confused. this is the y, and we can expand this form into other format like this. So basically you can read this format like the first parameter is the number of percentage in the y direction, and the second number is the resolution, which is the 40% of the cells will be occupied by the like the cells or the mesh, and the last parameter is the expansion ratio. So the expansion ratio is 4 in the let's say in the previous example, if we use like 10, 1 and 0, 1, it will be like 10, 1 and 0, 1. But if we make it in this format, it will be like only for this part will be divided again into some specific parameters. I hope you don't get confused. Maybe just make this example so you get the idea. So 0, 1 indicates that the 10% of the most bottom of the mesh have 0.4 or have 40% of the mesh. So if we have like 100 divisions, it will be occupied by like 40 cells. Then the last entrance, which is 4, is the expansion ratio. So the 10% of this bottom will have like 4 expansion ratio. Okay, then we can also do it for the other direction or other location, like 0.6. It means like from 0.1 to 0.7, because 0.6 plus 1 will occupied by 40% of the mesh. It is the same thing, but just different location. And the last line, which is the 20% of the rest, occupied by the 20% of the mesh. So it is better if you use consistent number like 0.3, because you can actually use if you input it all, not 100%, but it is easier to understand if we input it like this way. Okay, just try to run again. Maybe you can play a little bit about the values so you can get the idea better. So let's just check the y direction. You can see here like 10% occupied by 40% with grading for expansion ratio. I know it's a little bit confusing, but if you try to tweak some numbers, you will get the idea. Okay, then the last thing that I want to show is the edge grading. So edge grading is a little bit different with the simple grading. So we don't need these values. Edge grading. So we have edge like the 0, 1. So this is the 0, 1. This line is called the edge 0. Then 1, 2, and so on and so forth. Just follow this rule. So we will have like 1, 2, 3, 4. We will have 8 edges here because we have a cube. So it will be occupied by 8 values: 1, 2, 3, 4, 5, 6, 7, 8. And this grading will follow, like if we use this value, 1 is like the expansion ratio is 1. Let's say I want to make the grading of number 8 to be 10, let's say. It will be weird, but it will explain it easily. Oops. Expansion ratio. Oh, I think it is not this way. Wait a minute. Oh, I think we should have 12, not 8. of edges. Yeah, okay, here we go. Let's check this one, and here we go. So we only define the last edge with the expansion ratio of 10, and the other is only have like 1. So the definition will be like the edge by edge. It will be more flexible if you want to design a complex object, but you must be extremely careful to you know, like prevent the low quality mesh, which will lead you to error. And here we are, the end of this part.